right into the materials management and some of the definitions. The definition of materials management is concerned with the planning and organizing and controlling the flow of materials from their initial purchase through the internal operations to the service point through distribution. Or easier, material management is a scientific technique concerned with planning, organizing, and control the flow of the materials from their initial purchase to the destination. The aim of material management is to always get the right quality, the right quantity of supplies, get it at the right time, get it at the right place, and get it for the right cost. And the goal of the material management is to gain economy in purchasing, to satisfy demand during a period of replenishment, carry the reserve stock to avoid stockouts, stabilize fluctuation in consumptions, and to provide a reasonable level of client services. A good material management system will achieve the right price. It allows a high turnover of inventory. It gives a low procurement and storage costs, has continuity of supply, provides a good consistency in the quality, develops good supplier relations, and contains the costs, instills efficiency in all activities. So let's talk about material storage. Call it the stores, call it the central market, we call it a market area. Either way, we must have an adaptive and adequate space. The materials must be stored in the appropriate places in the correct way at all times. You should always look at a first in and first out principle when you're setting up your materials area. To monitor expiry dates and shelf life of all equipment, food, steel, and all products. Follow a two-bin or a double shelf method to avoid stockouts. It's always good to have a backup. The reserve stock should contain enough stock to cover a lead time and a small safety stock just in case there's an issue with supplies being delivered to the factory. Inventory control. Inventory control means stocking the adequate quantity in the proper location to ensure the availability of the stock at the point of use when it is needed. Inventory control ensures the needed supplies are on hand when required with enough reserve to eliminate stockouts. Stockouts are pretty much a shutdown. A simple approach to this, avoid stockouts and achieve a balanced inventory, is use a formula below commonly known as the economic order of quantity. There's several different versions of the economic order of quantity. The one I have here is really the simplest and easiest to follow. We should use selective control when we're talking about our inventory and how it works. When a large quantity of items are maintained in stock, it is necessary to rationalize the number of orders, the number of items, and reduce the inventory levels based on cost criteria. Something to keep in mind is 10% of the materials consume 70% of the resources. 20% of the materials consume 20% of the resources, and 70% of the materials consume 10% of the resources. It's commonly known as the 10-20-70 or ABC. ABC, always better control. A items, a smaller number, but consume a large amount of resources. That's the 10-70. B items are a small number, but consume a large amount of resources at a 20-20. C items are larger in number, but consume lesser amount of resources. That's really the 70-10. That's kind of how you want to look at setting up your inventory. You can use the VED analysis based on the critical value and the shortage cost of an item. It's a subjective analysis. Items are classified into vital, where a shortage cannot be tolerated. Essential, the shortage can be tolerated for a short period of time. Or desirable, where a shortage will not adversely affect, but may be using more resources. If you're going to put something in that category, it must be strictly scrutinized. Now we'll move into a plant layout. Facility layout significantly impacts material flow. A well-designed layouts reduce non-value-added movements and overall distance traveled within the facility. You want to get from point A to the point of use as quickly as possible and as safely as possible and as efficiently as possible. Facility layout should minimize the space required for materials and maximize the area for production. Materials is considered a non-value-added activity, so it's often hard to get the attention required and the investment needed, where production is really the bread and butter of the operation. So we need to ensure that our materials is always supporting our production as our customer. The materials layout should be set so a FIFO, first in and first out, is allowed. High bay racks are a very efficient way to accomplish FIFO. A proper FIFO layout allows for the minimum possible handling of parts also. Sequence and kitting cells must be taken into account when setting up the material layouts. Warehouse layout considerations. You have a U-shaped layout. Inbound shipments arrive and are unpacked at the receiving. Items are either moved to the storage or to a cross-docking process. Cross-docking means to take a finished good from the manufacturing plant and deliver it directly to the customer with little or no handling in between. So basically jumping from one trailer to another. Cross-docking reduces handling and storage of inventory. The step of filling a warehouse with inventory before shipping it out is virtually eliminated. So you can do more with less real estate. Flow-through layout designed to accommodate a large volume of cross-docking while having some storage capabilities for slow-moving items, which may not be cross-docking. Then you have a modular flow layout, which separates segments to design for specific warehousing applications. That's one of the more common that we'll see. Material flow considerations show you determine how you want to move your material. Do you want to move it manually? Do you want to tug it? Using a fork truck, AGVs and AGCs. And there's even other methods, such as the autonomous car right now Google's producing in such a way that it can be utilized in factories. Keep in mind the locations at the kitting and sequencing cells. Know where the parts are repacked prior to the point of use delivery. Ensure a quality call system is in place. Material flow and layout business case. Talk a little bit about a recent material flow and layout project that we did here at PMC. The client is a leading global supplier of lightweight noise and vibration solutions to the automotive and commercial vehicle industry. PMC was able to offer them a simulation model to validate the capacity envisioned by the client and find solutions to challenges faced due to capacity expansion. Our utilization and discrete event simulation techniques allowed the company to optimize material flow, balance the presses in order to meet future demands, design a layout, and optimize material handling equipment requirements to minimize the total CMA essential material area footprint in order to accommodate future parts along with current parts and eliminate double handling of material in a warehouse. When we walked in, everything was being handled 2 and 3 times, and there wasn't enough room to contain the materials they currently had, and they were expanding 2 more programs. So we had to find a way to fix that. The current warehousing techniques and inventory management at the plant have been proven to be inefficient to proactively manage the business, to improve the productivity and to meet the customer demands and the volume. With the space constraints at their current warehouse, the company had a challenging task to maintain their entire inventory in-house and avoid double handling of material, very, very costly. Acquiring additional warehouse space outside the facility would incur additional costs. Hence, there was a need to optimize the inventory with the space available at the present facility to minimize the cost of the storage and also to ensure on-time and efficient deliveries. So the approach we took is we went in, we took a data collection and validation, we created a PFEP, which stands for Plan for Every Part. We then set up a simulation modeling, an AutoMod. We did some layout planning, and then we input the material handling requirements into another program. Data collection for the Plan for Every Part. Data collection and simulation modeling is a vital process that highlights required data sets and their desired properties such as accuracy, sample period, and format to allow the simulation model to achieve the project objectives. A PFEP was developed with the data collected from the various sources and validated at the plant. Now I should say, due to the lack of information, the PFEP did take over a month to develop. However, it was a much needed object. Once we created it, they were already able to improve the productivity. The simulation model, the future layout provided by the client was imported to the AutoMod. The 2 different process flows, a truck schedule and a high-low routes, were implemented in the model. As an Excel interface was created to input data from the simulation model. So we created the Excel so that the client could actually make changes himself, send it back to us, and we could actually put it right back into a model form in a future state. This technique by PMC allowed the client to have the flexibility of changing the data on his own and run the model easily to meet future needs. The static calculations were done to validate the results in the model. The state-of-the-art racking system was designed in the CMA in order to maximize the storage space. We built all the way to the ceiling. The bulk area, the accommodated for a majority of high runners, Class A parts, with high number of pallets for 3-day inventory. The racks accommodated for the majority of Class B and Class D parts. Dedicated rack was allocated for Class C parts with provision for flexible part storage locations rather than fixed locations. Part flexibility for Class A, Class B, and Class D parts have been designed for all the racks based on the maximum and the minimum number required, and the average 3-day inventory level is derived from the results of the simulation model. By running a simulation model for multiple scenarios, the results were provided to the client to find the answers for the press utilizations and the hollow requirements and the utilizations, and the average inventory levels for each part type and the press schedule to minimize the inventory levels. In addition to the simulation study, the Excel interface was developed to the client for making the changes. CMA has allowed the client to avoid double handling of material by having dedicated space for each part. Materials is not a profit center and therefore is oftentimes ignored. Ignoring issues with the layout, with the flow, and the material efficiencies will have serious ramifications on the bottom line of the company. Issues caused by a poorly planned material handling system will cost money when ordering, will have adverse effects on a production system to include stockouts, causing long periods of downtime, even leading to losing customers. Excessive inventory is a drain on the real estate and the working capital and could eventually cause the demise of the company. So if I have to make one recommendation, I always say, ensure that your material handling and your inventory control is set up properly.